In this video, we explore America's most powerful secret weapon, the electromagnetic railgun. Show wide aerial shots of a futuristic U.S. Navy ship at sea, dark clouds and waves crashing, cinematic camera pan. Cut to close-up of a massive railgun mount on the ship, glowing with blue electrical energy, sparks flying. Show slow-motion firing sequence. The railgun launches a glowing metal slug at Mach 7, plasma and fire trail across the sky. Transition to infographic animation explaining how the railgun works. Electricity flowing through two parallel rails, projectile accelerating, arrows and diagrams glowing. Show impact shot of projectile destroying an enemy warship, explosion of metal fragments, slow motion cinematic view. Next scene, inside the Navy command room, officers and engineers controlling the railgun with holographic displays, glowing screens. Cut to futuristic test range with the railgun firing into the horizon, camera shaking on recoil. Show dramatic narration text overlay, the weapon of the future. End scene with epic cinematic shot of the railgun against sunset, text glowing. America's railgun, unstoppable power. Background should feel cinematic, realistic, documentary style, with smooth camera movements, 4K detail, dramatic lighting. Weapon number 1, railgun technology rocket introduction. The United States military has always been at the forefront of developing next-generation weapons. Among its most fascinating and futuristic creations is the electromagnetic railgun. Unlike traditional firearms or artillery, this weapon does not rely on gunpowder or chemical explosives to launch projectile. Instead, it uses pure electricity. The result is a weapon that can fire projectile at speed so fast that it could change the future of warfare forever. The concept of a railgun may sound like something straight out of science fiction, but the technology is very real, and the U.S. Navy has spent years developing it. To understand the importance of this weapon, let's break down how it works, why it is so powerful, and what it means for the future of global military power. High voltage, how does the railgun work? At its core, the railgun works on a simple principle, electromagnetic force. Instead of using an explosion to push a projectile, it uses magnetism. Here's how. Two parallel rails are placed close together. A conductive projectile, like a metal slug, is positioned between the rails. A massive electrical current flows down one rail into projectile and then back along the other rail. This creates a powerful magnetic field. The magnetic field pushes a projectile forward at incredible speeds. The projectile can reach speeds of Mach 6 to Mach 7, that's 6 to 7 times the speed of sound, or more than 5,000 miles per hour. Unlike a missile, the projectile has no explosives inside it. Instead, the sheer speed and kinetic energy are enough to cause devastating damage. Collision power of pure speed. To understand the destructive force of a railgun, consider this. A traditional tank shell might travel at Mach 1 or 2. A modern missile might reach Mach 3 to 5. But a railgun slug can reach Mach 7, almost twice as fast as most missiles. When something moves that fast, its energy upon impact is enormous. A railgun slug can penetrate armor, destroy ships, or wipe out targets without using any explosives. This makes it safer to store on ships, since there are no explosive warheads that could accidentally detonate. Waterwave U.S. Navy's interest. The U.S. Navy has been the biggest supporter of railgun technology. Why? Because of one main reason, long-range defense at sea. A railgun could fire projectiles over 100 miles away with pinpoint accuracy. It could destroy incoming missiles, enemy aircraft, or even ships before they come close. Unlike missiles that cost millions of dollars each, a single railgun shot might cost just $25,000. This is a massive cost-saving advantage. In modern warfare, where missile attacks can be endless, a cheap, powerful defense weapon is priceless. Battery challenges of the railgun. While the railgun sounds perfect, there are still challenges. Power supply. A railgun needs an enormous amount of electricity, often in the range of 25 megawatts per shot. A normal naval ship cannot generate that much power. That's why only advanced warships with nuclear or advanced generators can even think of using one. Wear and tear. The rails suffer extreme heat and stress every time the gun is fired. After just a few dozen shots, the rails may need repairs. This makes the weapon hard to maintain. Size and weight. Railguns are huge, often the size of a bus. Fitting one onto a ship is not easy. Cooling. The heat generated by firing is intense. Advanced cooling systems are needed to stop the weapon from melting. Globe showing Europe-Africa global impact of railguns. If the U.S. successfully deploys railguns, it could redefine naval combat. Enemy ships would have no chance of approaching within missile range. Aircraft and drones could be shot down before they even launch their attacks. Ballistic missile defense would become much stronger. In other words, whoever controls railgun technology controls the seas. Crystal ball future possibilities. The railgun is not just a weapon. It's a platform for future innovations. Hypersonic defense. Railguns could be the ultimate defense against hypersonic missiles, which are otherwise very hard to stop. Space launch. Some scientists believe railgun technology could eventually be used to launch satellites into orbit at a fraction of the cost. Land-based defense. Railguns mounted on land could protect entire cities from missile attacks. Movie camera scripted narration, YouTube style. Imagine a weapon that doesn't need gunpowder, doesn't need explosives, but can still destroy anything in its path. This is not a science fiction movie. It's the U.S. military's railgun. Using electromagnetic energy, it fires a projectile at 7 times the speed of sound, striking its target with unimaginable force. The U.S. Navy believed this weapon could change the future of war forever, making ships nearly untouchable and providing a defense system like never before. But the challenge remains. Can America overcome the technical problems and truly unleash the power of the railgun on the battlefield?